Hi everyone, welcome. This question binary search is a textbook question to be solved using the binary search algorithm. The question says, given an integer array nums already sorted in ascending order and a target variable target, we want to find where the target exists in the nums array and return its index. And if it does not exist, we return -1 as an index. And importantly, the function we're going to write needs to achieve a runtime complexity O log n. So how do we achieve this goal? The first thing you need to know is the concept of floor division. So floor division returns the integer part from the division or the quotient. So for example, 7 divided by 2 is 3.5, and the floor of this number is 3, and the ceiling is 4. So the floor division implemented by double slash in Python gives you 3, the floor from 3.5, and the modulus will be will be 1, the remainder part. And if you have -7, it will be -4, because that's a floor from minus 3.5, and the modulus will be positive 1. Now I will talk about the binary search algorithm, a decrease and conquer algorithm that reduce the original problem to roughly half of the original size each time, and is known to have a time complexity O log n. So the idea is to use the middle as an estimate, and it depends on whether the middle is the same or larger and lower than the target. Then we look at the remaining half, either the left half or the right half, as the next iteration. So first of all, to get the middle index, we assign the left index to be the first element and the right index point to the last element. And then instead of using simply left index plus y index divided by 2, which might have an overflow problem like 3.7 divided by 2 equal to 3.5, we use a floor division to control overflow. Specifically, we use a double slash, therefore 7 floor divided by 2 will be 3. And we point that point to the middle element. And depends on whether the middle element is the same as target or not, we move to the next step. If it's the same as a target, then we return the middle index as it. If the middle element is larger than the target, it implies the target must exist in the left half chunk of the remaining array. So we move the right index to the immediate left of the middle index to form the new right index. Finally, if the target is larger than the middle element, we know that the target must exist on the right half chunk of the remaining nums array. Therefore, we move the left index to the immediate right of the middle index to form a new left index. With all the background knowledge introduced, we're now ready to write the code. So first of all, we have a left index pointing to the first element and the right index pointing to the last element in the nums array. And then we have a middle index pointing to the middle element, and we use a floor division of the sum of the two indexes by 2. And then we have a middle element. And then the question is simply whether the middle element equal to the target. Because if it is, then we'll simply return the middle index because we found a solution. And else, if the target is larger than the middle element, it means the target exists in the right half of the remaining nums array. Then we will move the left index to the immediate right of the middle index. And finally, if the target is less than the middle element, it means the target exists in the left half of the remaining nums array. Then we move the right index to the immediate left of the middle index. And if throughout all this process we cannot find the answer, then we'll return -1. But before we return -1, we do it iteratively in a while loop. And while the left index less or equal to the right index. The reason for that less or equal is because we allow then with the stand as the middle index can be the convergence of these two to the stand index. And so this is the floor division to avoid index overflow. And now we submit this to see if it works. So submit, and pending is judging, completed. So let's see the result. It's accepted with 196 milliseconds. So we now analyze for the complexity. So since we use the binary search, it has a time complexity O log n, and since we all use a constant space here, then it has space complexity O1. Thank you so much for watching.